All right, this is lesson 4. We're dealing with properties of exponents. And what properties we're talking about, I'm going to actually show you with the calculator. So make sure you have a calculator. If you don't have one, just pause the video right now and go grab one. So use the calculator to check your work. So if you take a look, if we go in the calculator here, 2 to the power of 10. Remember, hit the over key so that cursor goes down, times 2 to the power of 3. And you get 8,192. Now, that's easy, but there's also another way to look at this. If you look here on the calculator, do 2 to the power of 13. And notice you get the same exact answer. Now, where did that come from? It actually came from the fact that when you're doing this, you can just simply add the exponents. Why does that work? Well, if you think about 2 to the 10, and let's look over here in the calculator. 2 to the 10 is 2 times 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 of those. That right there is 2 to the 10th. Well, then I times 2 to the 3rd, so I'm putting in another multiplication sign. And then 1, 2, 3 more. So I actually have 13 of these 2's. So if you take a look at this, on this page over here now, 5 to the 4th is 5 times 5 times 5 times 5. I have 4 of them. 5 to the 5th is 5 times 5 times 5 times 5 times 5. And if we're going to multiply them, I end up with 5 to the 9th. So you could just shortcut it and just say 5 to the power of 9, some ridiculously gaudy number. So the same thing here. We can look at this and say this is 8 to the 10th. You can scroll down a little bit and say this is 3 to the 9th. This, well, wait a minute, I have an x here. Well, that's x plus 4. Why is it x plus 4? It's because I'm just adding the exponents here, the x here, and then the 4 here. It's the same thing I did over there. So if you take a moment to pause the video and try to get this, what would I do for here? And just leave it like that, x plus z. Looks like a 7 when we fix that. So what pattern do you see in every case? You're adding the exponents. And hopefully it makes sense from where we get that from here and here in the first example, where really what the 2 to the 10th is repeatedly multiplying by 2 10 times, and this is repeatedly multiplying by 2 3 times, which is repeatedly multiplying by 2 13 times, 9 times here, 8 times there, and so on. Now, here are some common mistakes. So pause the video and see if you can find out what the mistakes are before we go over them. Hopefully you took a minute to pause and look at the video. So this right here, we don't do 3 times 5. 3 to the 5th is this. That's 9, 27, 81, 243. This here, 3 times 3 times 3 times 3 times 5 times 5. Notice there's not this. There's not 8 powers of 15 here. That doesn't even make sense. But it's a problem that students have, and I see the mistakes all the time. So just be careful about this. This does not work. If you want to go back and look at this problem and say what this is, unfortunately, there's not much you can do here to simplify it. So this is really just that, and it's the same thing. If you take a look here, we can't multiply this as well, and we cannot add these exponents. Look here. The only way we can add these exponents, go back up here, is if the powers are the same. See how I have all powers of 5 here, and all powers of 2 here, and all powers of 8 there? If you go here and again write down what we have, there's nothing to combine here. There's no 6 powers of anything. There's still 4 powers of 3 and 2 powers of 5. So we can't really simplify that. Down here, I know the rule is add the exponents, but that only works with multiplication. If you think about this, doesn't make sense. This is 3 powers of 3 plus 2 powers of 3. So we can't add the exponents. This, again, does not work. Those are little tricks that people make mistakes on quite often. Hopefully you can avoid them. and understand what these powers are and how they work. And again, if it ever, struggles, go back to what is 5 to the 4th, what is 5 to the 5th. That's what it is. Lay these things out. Now, if you do that, if you lay those out, and this is on the next page, hopefully this will make sense about what this is. 2 to the 3rd to the 4th power is 2 to what power? Well, let's think about it. 2 to the 3rd is this. So if I break up the 2 to the 3rd, and I have 4 of those. So what does that really mean? I have 1, 2, 3, and 4 of them. So when you write this out, how many powers of 2 do I have? 1, 2, 3, 4, 5, 6, 7, 12 of them. So this is 2 to the 12th. So same thing here. I have a bunch of powers of 3. That's 3 to the 5th. And it tells me I have them 2 times. So raise this to power means I have them 2 times. Which means I really have 10 powers of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here, if I have 2 powers of 5, how many groups of them am I going to need to get 6? Well, hopefully you should see that it's 3, and x is 3 groups of them. Here I just changed up and I said a letter. I have 2 b's to the 5th power, which means I have 5 groups of b. So 5 groups of b times b, which means I have 10 of them. So another shortcut, if you want to look at a shortcut, is just this times this equals this power. So 3 times 4 is 12, 5 times 2 is 10, 5 times what is 6? That would be 3, 5 times 2 is 10 again. So the pattern that you're looking at here is they say power to a power, you multiply. So what kind of mistakes can you see from this? Well, the correct answer should be 4 to the 3 times 2 should just be 4 to the 6. Don't make the mistake of putting 4 to the 5 and other examples you can think about. This is 4 to the 6. Really think about this as 4 times 4 times 4, which is 4 cubed, and I have 2 groups of them. So I have 4 to the 6th power. If you think about it this way, you really can't make too many mistakes, and it's pretty straightforward to solve. But if you just kind of shortcut it and try to get these 2 things, you could possibly get them mixed up on the quiz. So just be careful about the practice section of the quiz. Good luck.